Our lesson today is about deductive logic. Please do not confuse this with inductive reasoning that we were working with last week. When we examined inductive reasoning, we saw that that was following a pattern and coming up with a conclusion. Usually we would follow a pattern and create a conjecture. These are going to be different from there in that we're not following patterns. Deductive reasoning is different because deductive reasoning is based on rules. We only have two objectives for today. We want to be able to use the law of detachment to make a logical conclusion. We also want to use the law of syllogism to come up with a logical conclusion. I will let you know it is not important for you to memorize the names of these things. I don't care if you memorize the name detachment and syllogism. It's more important that you be able to use it and understand what they do instead of knowing their names. In particular, deductive reasoning is a process where you analyze and use logic to come up with a conclusion. It's different from inductive reasoning because inductive reasoning uses patterns. Deductive reasoning uses some kind of a law. It's a fact. It's a definition. It's some kind of a property. And you can frequently find these things where it'll be in a textbook or the teacher says this is a rule that we're using. But in general, deductive reasoning is based on following some kind of known fact or rule. Inductive reasoning follows a pattern. And so the first thing we want to be able to do is identify, are we using inductive logic or deductive logic? And here's our first example. Is this conclusion a result of inductive or deductive reasoning? Now, there is a myth that you can balance an egg on the spring equinox. Now, let's say that one person was able to balance their egg on July 8th, September 21st, and December 19th. And then we have the conclusion, the myth is false. Did we use inductive or deductive reasoning to come to that conclusion? You said deductive. Why? There is this piece right here that's making a claim. It's only possible to stand an egg on its end only on the spring equinox. That is a rule that is claimed to be true. Operating on the assumption that the rule is true, we then present evidence, and that evidence shows us that it's not. Because we're using evidence and not following a pattern, that's deductive reasoning, leading us to the conclusion that this claim is not actually true. The myth is false. Okay, consider another example. There is a claim that eel skin wallets will demagnetize and damage credit cards because the skin of an electrical eel is going to retain an electrical charge and that can damage the credit card. So here is a claim for a law. In actuality, though, we can present some evidence and say eel skin wallets are not made from electrical eels. They're made from different kinds of eels. Based on that, we reach the conclusion the myth can't be true. So is that inductive or deductive reasoning? Did we follow a pattern, or did we use some kind of rule and evidence? We used a rule. The law was the claim about the wallets. The evidence was that they're not made from that, and so we have a deductive conclusion. Now, when we work with deductive reasoning, the two main tools we will use are the law of detachment and the Law of Syllogism. Both of them have a structure that allows us to reach conclusions. We know before that the only way for a conditional to be false is to have this format. True implies true equals overall true. False implies anything is overall true. This is the only way for something to go false. And so we are going to take advantage of this structure. We're going to know it. All right, so how are we going to take advantage of the structure? Let's say that we know the statement is currently of the form true implies blank. So we already know that the beginning, the hypothesis, we already know that the hypothesis is true, and we already know that the conditional is overall true. Because the statement is overall true, we know it cannot have this format. And so if it does not have the format of true implies false, that of course forces it to have the format true implies true. This is the law of detachment. If you start off with the stuff in red being true, if you know you have a true hypothesis, and you know you have a true conditional, that forces the conclusion to also be true. This particular thing is incredibly important for us, because what we will frequently do throughout geometry, we will very, very often have theorems. And so what we wind up with, the theorem takes on the role of the conditional. We will prove a theorem and say, this always works. As long as you set up our hypotheses, as long as you can verify the hypotheses are correct, the theorem is going to give you the conclusion. And so throughout geometry, we will very frequently see the beginning part is something that you do the work to show that it's actually correct. Because of a theorem, which is a rule or a law known to be true, it then forces from detachment that we will get this piece for free. The structure will be very important for us throughout the year. And so we want to start by applying it. Before we start looking at very specific mathematical theorems and how to apply them, we want to use examples that are a little bit more general, a little bit more broad. And so we're starting off here. Here is a given. Anytime you see the word given, that means we are giving you this thing is true. We can accept it as a fact. And so here is our fact, or the law that we're beginning to work with. We know that this stuff is true. If the side lengths of a triangle are 5, 12, and 13, and so this is not a very accurate drawing of a 5, 12, 13 triangle, just a pretty sketch. But if you have a triangle with sides 5, 12, 13, it will force the area to be 30. This is a law. It's a rule that we're working with. So let's come over toward here then and say, here is a particular triangle, PQR, and side lengths are 5, 12, and 13. Based on the example and based on the law, what do you instantly know about the purple triangle? Its area is 30. Because the law is telling us any triangle with 5, 12, 13 sides has an area triangle. This is one of them. And so the law of detachment tells us the area has to be 30 centimeters squared. That's it. We're done. Okay, here's another one. using an example outside of shapes. Here's a fact about a lot of sports. When you get to the World Series or like the NBA Finals or a lot of sports, the first team that gets to 4 wins gets to be called world champions. That's a fact that we know. In baseball, the first team to win 4 games wins the series. Same thing with the NBA Finals. First team to 4, series is over. So, we're now going to look at a specific example. In 2004, the Red Sox got 4 wins in the World Series. Based on the law of detachment, what do you instantly know? They won. They were the World Series champions that year. That's the law of detachment. The second form of deductive reasoning we will use is the law of syllogism. Now, the law of syllogism combines 2 conditional statements in a very particular way. Syllogism applies when we have one statement and we know that this is overall true. Then we would take a second statement with the structure Q implies R, and that is overall true. Syllogism tells us that if we have these 2 things, basically P causes Q, and then Q causes R, together, that would tell us we can just cut out the middleman and get P causes R within a chain. That's syllogism. And so we want to concern ourselves when we look at statements, does this structure exist? If the structure exists, we know that the bottom conclusion, P implies R, is actually going to work, that it's valid and correct. If the structure is not there, the whole thing falls apart, and we would need different investigative techniques to see if something is true or false. And so, consider this. Does it fit the structure for the law of syllogism? Yes or no? That's telling us we have to start off with P implies Q. Check the first statement then. If a figure is a kite, that's our P for the first hypothesis. Then it is a quadrilateral. There's our Q. And I'm picking them just so that it fits the law of syllogism. Now we'll continue further. If a figure is a quadrilateral, does that connect back to what we had before? What is it? Figure being a quadrilateral tells us, well, quadrilateral was Q, so I'm going to use the same letter. Yes, it is a hypothesis for a second statement, but we can't always use the same letter P for many different hypotheses. Continuing further, then it is a polygon. Have we had a statement about polygons? No, so I'm going to call that R. Does this fit the law of syllogism structure? Yes, it does. Because of the structure that exists here, we now get the conclusion P implies R will be true. As long as we still need to verify, were both of those true to begin with? Yeah. If both of them were true to begin with, then we would know that's going to cause P implies R to be true. So let's verify that. If a figure is a kite, well, what does a kite look like? That's a kite. Is that a quadrilateral? Does that have 4 sides?
Yeah.
Yes. So that tells us then this one was true. That's correct. Verify the next one. If it is a quadrilateral, then it is a polygon. Polygon, of course, just has many different sides. Well, if you have a four-sided shape, does it have many sides?
No.
Yes. Yes, it does. And we'll look at polygons a little bit more and just refresh your memory exactly what they are and what some of the rules are. But that one's true also. So based on these, we now know this is a valid conclusion based on the law of syllogism. The structure is there. Both of the original conditionals are true. That truth, combined with the structure, then gives us the second conclusion is also true. Okay, consider this now. Is the conjecture valid? If a number is divisible by 2, then it is even. If a number is even, then it is an integer, leading to the conclusion that if a number is an integer, it is divisible by 2. Is that valid? Well, let's start by checking for the structure. A number is divisible by 2, then it is even. Is this true or false? Yes, this is overall true. Even numbers you can divide by 2. Not a huge shock there. Continuing further. If a number is even, then it is an integer. Is that true or false? That's false. This is saying if you have a number that's even, then it will be an integer. And I have to backtrack myself a little bit. You were correct. I don't know what happened in my brain, but in my brain I had this backwards where I was thinking integer for the hypothesis, even for the conclusion. I don't know why I was thinking that, but the thoughts in my head were wrong. And so we then recognize P implies Q is true, Q implies R is true. Based on the law of syllogism, we now know that P implies R is overall true. Was that the conclusion then? The conclusion, if it's an integer, then it's divisible by 2. The actual conclusion had the order backwards. Everything was set up for the law of syllogism, but the actual conclusion didn't fit the conclusion that we needed. So because this has a backwards order from what we were supposed to have, this is not a valid conclusion. It doesn't, we don't know if that's true or not. One last example before we're finished here. If an animal is a mammal, then it has hair. Is that true or false? Okay, so initial thoughts that people are saying right now, that's a false statement. So if it were false, we would already know that we can't use the law of syllogism, that the whole thing breaks down. Let's continue and see if we can find some other issues though. If an animal is a dog, we haven't done anything with the dog yet, that's a new statement. So I'm going to call that R. Then it is a mammal. Well, being a mammal was P. And that's one that we know is true. Dogs are mammals. Leading us to the conjecture, if an animal is a dog, then it has hair. Does this fit the structure for the law of syllogism? No. No, it does not. And so we know that this would not be a valid conclusion Even if it were a true statement, it's not a valid conclusion because it does not fit the structure that we need. We either have a problem with the first one being false, or we have a problem with the structure not being correct. Either way, we've got a problem. This is not valid logic. And then here is our last example. Actually apply the law of syllogism and come up with a conclusion. Here's something that we are given, so a given means we know that this is true. If a polygon is a triangle, then it will have 3 sides. Okay, we know that's true. If a polygon has 3 sides, then it is not a quadrilateral. Which is also true. So here's the structure we have. These sentences fit the format. P implies Q is true. Q implies R is true. Now, we also know polygon is a triangle. What conclusion can you then draw? All of these pieces that are written in the blue, those are things that we are told are true. So what conclusion does it connect to? That connects to R, and so this is syllogism combined with detachment. Since R is true, we'd be able to say polygon P is not a quadrilateral. That's how we would apply the logic. I want to verify that people can see how the structure is actually being applied. Come on. We started off with these pieces being true. Based on syllogism, we knew that this format was a true statement. By itself, that doesn't tell us anything about P and R. That would only allow us to simply say P could have been a false statement to begin with, in which case false implies whatever is still overall true. But this piece got tied into it, telling us that this actually was a true component. Knowing that that component was true, we could then apply detachment, and that's what got us the R being true also. This particular problem actually combined both forms, syllogism and detachment. Again, I don't care if you know the names, and I know I've said them a lot just to try to reinforce them a little bit. It's in the nice to know list. The names are nice to know, but being able to follow the structure like I had here in the yellow, being able to reach the conclusion for R like I did with the red, those skills are necessary. The names aren't important, but understanding the logic is.